All right, let's jump right into this explainer by confronting a very specific and honestly slightly uncomfortable reality. Right now, there is a metaphorical rat in your brain. It craves absolutely nothing but dopamine, and it thinks that 10 minutes of focused attention is an absolute eternity. Look, if you're trying to learn how to code, this rat is basically your biggest enemy. And today we're going to dive into the science of exactly why you need to ignore it if you want to build any real lasting skills. I highly recommend grabbing a notebook for this one, guys, because today we are taking a slightly more educational look at the very real struggle of learning to program in the age of artificial intelligence. We're going to look closely at a recent fascinating experiment where novices were observed as they tackled a beginner programming task. Spoiler alert, everyone actually finished it, but how they finished revealed some pretty startling truths about how our brains react to boredom, to difficulty, and to that instant gratification we get from AI tools. Here is our roadmap for today. We'll start by tackling the vibe coding problem, then explore the power of pausing, break down 5 classic coding traps, uncover 3 brand new AI traps, and finally wrap things up with metacognitive awareness. Okay, section 1, the vibe coding problem. Let's see how those novices in the recent experiment actually performed when they were given an AI tutor to help them solve a coding task. Put simply, some were great and some were not so great. But the wild part is that the difference wasn't about raw intelligence at all. The difference was in how much they actually paused to think about the problem before they tried to solve it. See, in the experiment, every single student found a solution within their 30-minute window, largely thanks to their AI tutor. But researchers noticed something deeply concerning. The students who offloaded all the actual problem-solving to the AI were completely oblivious to their own incompetency. Like, they genuinely thought they had solved it mostly on their own. And this right here is what we call vibe coding. Look, vibe coding is fantastic if you're a professional just trying to crank out a task. But if you're a student, it is terrible for learning because you completely bypass the cognitive development you literally need to understand the systems you're building. And this brilliantly illustrates how our behavior has completely shifted when we hit a wall. Historically, getting stuck meant a forced pause. You had to look it up on Stack Overflow, maybe bug a friend, or, just sit there and think. But since AI coding assistants came onto the scene, typing out a prompt and reading the generated output feels infinitely more productive than just sitting in an empty pause. Our dopamine rat gets fed immediately. But we really have to ask ourselves, is avoiding that empty pause actually doing us any favors? Moving right along to section 2, the power of pausing. We really need to flip the script on how we view those empty pauses and those incredibly uncomfortable moments of confusion. If your actual goal is to develop your thinking, you simply have to give yourself a minute to actually think. So the crucial takeaway here is this. Pauses in learning aren't just normal, they are absolutely necessary. Even if they feel totally unproductive in the moment, struggling, getting stuck, getting frustrated, these are not red flags that you can't solve the problem. In fact, those feelings are literally what solving a problem feels like most of the time. Thinking is just a messy, frustrating process, and if you try to short-circuit it with AI, you are paving a fast track to a smooth brain. Let's look at a play-by-play of how this happened in the study. Subject 7 read the prompt and started coding. Almost immediately, they got completely overwhelmed by an AI autocomplete suggestion. And instead of working through it, they interpreted this brief moment of confusion as a definitive sign of failure. So within literally 10 seconds of starting the task, they abandoned their own code, opened the AI chat, and just asked it what to do. 10 seconds. They didn't even give themselves a fighting chance to struggle. All right, section 3, 5 classic coding traps. So, to avoid throwing in the towel after just 10 seconds, we need to learn exactly where our brains tend to derail. Researchers have pinpointed 5 classic traps that beginners fall into when learning to code. Get that notebook ready because spotting these in real time is your absolute best defense. This table breaks down exactly where the study's participants went wrong. First up is forming. This is when you have the right question but the wrong answer. Participant 1 understood the goal but wrongly started summing numbers instead of actually counting them. Second is dislodging, basically getting stuck in a rut. Participant 4 just kept editing code that checked for even and odd numbers, completely unable to make the mental jump to actually counting them in a list. Third is assumption. Wrong question, right answer. Participant 21 fell for this by hard-coding variables for exactly 4 numbers. I mean, the code worked perfectly as long as you literally never wanted a 5th number. Fourth is location, which is skipping a crucial step early on. Participant 9 wrote these beautiful input-output statements, but entirely forgot to include a loop, which meant a massive structural rewrite later.
And finally, fifth is achievement, which is like putting a Band-Aid on a broken bone. Participant 1 just kept throwing nested loops and conditionals at the wall, endlessly tinkering with a fundamentally broken structure instead of just biting the bullet and starting over.
Which brings us to section 4, 3 new AI traps. Now, logically, you'd think, right? You'd think having an AI tutor would help us sidestep those 5 classic pitfalls. But the researchers found something super fascinating and honestly a bit alarming. AI tools actually make things harder by introducing brand new cognitive difficulties that are specifically tied to the technology itself. That's right. AI coding assistants have introduced 3 new traps for beginners that previous generations of programmers literally never had to deal with, and we need to watch out for them carefully. Let's look at the first one, the progression trap. This is a sneaky one. It's when you think you're keeping up with a course, but you're actually falling way behind without even noticing it. Participant 8 fell right into this one. They used an LLM to generate a passable solution for a very simple while loop. The AI essentially had to spoon-feed them how to initialize variables, which is a concept they should have mastered weeks prior. In their post-test interview, the student claimed the AI, quote, validated their ideas. But in reality, they didn't have any ideas. They just used the AI to skip the thinking part entirely, completely masking the fact that they were weeks behind the curve. Next up is the interruption trap. Listen, when you're a beginner, it takes a massive amount of brain power to pause and think your way through a logical solution. So every single time an AI code completion tool throws an unsolicited, unfamiliar block of code at you via a pop-up, it violently breaks your train of thought. It forces you to spend precious mental energy reading and interpreting code you didn't even write, which completely derails your own problem-solving process. Interestingly enough, the study noted that the non-struggling students mostly just ignored these autocomplete suggestions altogether. And the final new difficulty is the misleading trap. This happens when you trust an AI suggestion that sounds totally plausible, but absolutely sends you off a cliff in the wrong direction. Participant 11 accepted some pretty bad AI advice to some positive and negative numbers rather than just counting them. Sure, they eventually realized the mistake, but the sheer amount of time and energy it took to backtrack and fix that AI-generated error was massive. Okay, let's wrap this up with section 5, metacognitive awareness. So, we've seen the 5 classic traps, and we've uncovered the 3 new AI traps. What's the actual fix here? We need to understand the psychological tool we can use to fight back against our own dopamine-craving brains so we can learn properly. Researchers use a term for this, metacognitive awareness. Yeah, it's not the sexiest term in the world, but it is incredibly powerful. It's simply your ability to recognize these common traps in your own thinking while you are right in the middle of them, and then actively problem-solve your way out. And get this, research proves that simply teaching beginners about these common metacognitive difficulties, just knowing they exist, produces immediate and lasting changes to a learner's productivity, their independence, and their confidence. Look, external AI tools just aren't built to protect you from your own thoughts right now. You are the absolute sole expert of your own mind. So you have to find active ways to remind yourself of these 8 traps. Literally write them on a Post-it note and stick it to your monitor. If you're pair coding, politely point them out to your partner if you see them getting stuck in a rut. Take a second to reflect on which traps you personally fall for the most. Like, do you skip steps? Do you double down on bad code? Remember, you have to embrace the productive annoyance of learning. Getting frustrated just means you're doing it right. Ultimately, it all comes down to a choice you have to make every single time you sit at your keyboard. You have to decide if the instant gratification and pure convenience of vibe coding is actually worth sacrificing your long-term cognitive development. That dopamine rat in your brain really wants the AI to do the thinking. But keeping these 8 traps in mind is going to help you protect your brain, embrace the pause, and actually master the craft. So the next time you get stuck, I'm going to leave you with this. Will you just type out a prompt, or will you take a deep breath and actually think? Enjoy your learning.